CVT transmission computer control. The CVT transmission has 3 PWM or pulsed width modulated solenoids. These are the line pressure, secondary variator pressure, and torque converter clutch solenoids. The line pressure solenoid controls the position of the line pressure regulator, based on input values from the transmission computer. The typical resistance of the line pressure solenoid is between 4 to 9 ohms. Additional to the PWM solenoids, the CVT also has a single on and off solenoid that controls the TCC lockup valve. A variety of diagnostic trouble codes or DTCs will be generated, depending on a circuit or mechanical failure with the line pressure solenoid, or codes like P0746, P0962, and P0963. As seen in this 2D animation, the secondary variator pressure control solenoid controls the position of the secondary variator pressure control valve. This valve regulates the release of fluid from the secondary variator during pulley adjustment, from high ratio to low ratio. It's very important for this solenoid and valve assembly to work properly. The CVT relies on the secondary variator to provide the necessary clamping force on the belt. As a feedback system to the TCM will look at the secondary variator pressure sensor to determine if the solenoid is operating properly. All the baseline pressure lookup tables are pre-programmed into the TCM. If the actual and target pressures don't match, a faulty code will be issued by the transmission computer. The primary ratio control solenoid, also attached to the ratio control valve, can also effect a valve change electronically. The ration control valve is mechanically linked to the primary variator by means of a control arm link. So, as the primary variator moves, so does the ratio control arm, and therefore, the ratio control valve. As you can see, the feedback here is real-time, coming right from the movement of the primary variator. If the TCM deems necessary to further control the variator, it does so by means of the ratio control solenoid and the stepper motor. The stepper motor, as you can see on the animation, even further adjusts the opening or closing of the ratio control valve. All these 4 components, the ratio control valve, solenoid, stepper motor, and ratio control solenoid, are mechanically and electronically interlinked. Looking at the CVT wiring schematic, you might notice the ROM assembly. This is a microchip, programmed when the transmission was assembled, and carries specific information on the variators and hydraulic system, and it's done so this way because no 2 CVTs are the same. There are always some minor manufacturing differences. This ROM should never be interchanged with any other CVT. It is unique to the CVT it came with because of these subtle manufacturing differences. If you ever replace a CVT, while reusing the original transmission computer as it is always done, or swapping the original TCM with a used one, a calibration mismatch code P167A will set. You'll have to use a factory scan tool to go through a calibration procedure to recalibrate the TCM and ROM. Also, if you install a new TCM, a code P1679 or calibration not learned will set in memory, needing another reprogramming procedure at the repair shop. Nevertheless, it is important that the ROM assembly be kept with its original transmission. The transmission connector has 22 pins, but not all of the pins are used. The JATCO CVT-equipped vehicles use the Controller Area Network or CAN for inter-module communications, so all kinds of parameters are interchanged through the CAN network. These parameters may include the TPS, MAP, ECT, CKP and RPM values. At the schematic, there are no dedicated circuits for engine speed, throttle position or load. The TCM uses the CAN for these main inputs. So, as you can see, in these CVT-equipped vehicles, the use of the CAN network is far and wide. Although you might not have seen one of these CVTs in your shop, it's definitely time to get ready for this technology. CVTs, in spite of all their previous issues, are the next trend for the automatic transmission industry. Multi-speed automatic transmission, even a 9-speed from Mercedes, are being introduced every day, but they'll never achieve the infinite number of ratios found with the CVT. There are a few things the CVT might not handle well right now, including weight and high torque capacity. But don't be surprised to see these CVTs even in light-duty trucks in the future.